In this problem, we want to find F1, one of the forces, knowing the fact that I have a resultant force that equals 600 newtons along this U-axis. So I'm giving F2 and F3 and the resultant force, and I want to find F1. Okay, so the first step that we need to do is we need to write each force in Cartesian form. That is, find the x and y components of each of the forces, each of the three forces as well as the resultant force. So my unknown force is actually F1, okay, and it's at an angle of phi from the x-axis. So I have F1 cosine since it's adjacent to the x-axis, and F1 sine in the y-axis since it's opposite of that phi. Okay, so F2 is the 650 in the x direction, and it's going to be 3/5 because 3 is on the horizontal, 5 is along the hypotenuse, so it'll be 3/5 in the x direction, and that's heading in the negative x direction. Okay, so 3/5 times 650 is 390. The vertical is 4 over the hypotenuse, so 4/5 times 650 is 520, and that's in the positive y direction. Moving on to F3, that's the 500 newtons. That's going to be sine and cosine of 45. Now, of course, 45, sine and cosine of 45 are equal, so it's just 500 cosine 45, 500 cosine, or sine. It would be the same thing. And that would be in the positive x direction and the negative y direction. My resultant force is going to be, again, 600, given here in the problem statement, along the u-axis, which is 45 degrees above the x-axis. So that's also going to be sine and cosine of 45 in the x and in the y direction. So I have the magnitude or the component of each of the forces in both the x and y directions. My unknown here is actually one of the forces I'm adding together. I know the resultant in this. So now when I add up the x components and add up the y components, I'm solving for something other than the resultant. So in the x direction, my resultant in the x direction is 424.6, and that's going to be equal to F1 plus F2 plus F3 in the x direction. So that'll be F1 cosine of phi minus 390, again because F2 is going to the left in the negative x direction, plus 353.4, which is the x component of this 500 newton force. Okay. So solving that for F1 cosine phi, I get 460.7. So again, I'm solving for something other than the resultant. Add up each of the components and set them equal to the resultant in this case. I do the same thing in the y direction, where I'm going to have my resultant in the y direction is 424.26, again because I'm at a 45 degree angle. It's the same. Okay. Then I'm going to have F1 sine of phi plus 520, which is the y component acting upward for F2, minus 353.53, and that's because this 500 newton force is acting downward in the y direction at an angle of 45 degrees. So that's my other equation. Solving that for F1 sine phi, get equal to 257.18. Now I have two equations and two unknowns, right? I don't know F1 or phi, and I have this equation as well as this equation. Now, if you remember from trigonometry, I can simply divide these equations. Okay, sine divided by cosine gives me tangent of my angle phi, which is going to equal 257 over 460.7. Okay, doing an inverse tangent function on that, I can figure out that my angle phi is 29.2 degrees. Plugging 29.2 degrees in either one of these equations, I can solve for F1 and find that it's 528 newtons. So again, with these Cartesian problems, you write each force in both the x and the y directions, sum up the forces you're adding together and set it equal to your resultant. You're not necessarily always finding the resultant. In this case, we had the resultant. So you're solving for a different force than the resultant. That would be F1 here. So you add up each of those forces, set it equal to the resultant in both the x and the y direction, two equations, two unknowns, and you can solve the problem.